Hi and welcome to another episode of TRX Bench. And as you already can see, we have here a Thermo power meter on the bench, and it came in for testing, and if needed for calibration. And I mean, I'm not a calibration lab, so we can certainly do a bit, but I am not as precise as a calibration lab is, so I'm far away from being a calibration lab. But anyways, so that is from a radio amateur, and he said, well, it doesn't matter if it is not absolutely calibration lab quality. I just wanted to have it, more or less in spec, and that would be fine for me. And then I said, okay, so that is what we can do, but well, it will never be the same as a calibration lab. Okay, anyways, let's start. So first of all, you see it is already switched on, and the unit is on for approximately 1 hour. And that is important because you never should do any calibration jobs if unit is cold. It's the same for my frequency generator, so that is as well running for longer than 1 hour. So that is very important, and therefore that is now the starting point where we can try and see what's really going on. So what you see, the calibration, or not here, our power meter goes from below 0.3 milliwatt up to 100 milliwatt, so that is quite sensitive. I mean, it is still not as sensitive as I don't know, a spectrum analyzer, for instance, or for a special high value power meter. So 0.3 milliwatt, which is 300 microwatt, is approximately minus 5.2 dBm. So that is still quite high level compared to what levels we are dealing with our radios. Just to remember, minus 73 dBm is an S9 level on our shortwave radios. So, and if we are talking here about 300 microwatt or minus 5.2 dBm scale end here, so yeah, that is still quite a lot. And I do not really know how reliable the low readings would be. I mean, if we go here to our lower scale, 300 microwatt is scale end, so that means our 10 is 100 microwatt, and so this indication here in the middle would be 50 microwatt, and even 50 microwatt is far away from minus 73. So 50 microwatt is converted into dBm minus 13 dBm. So now you get an idea what the sensitivity of this meter is. So, well, to be honest, this might be a kind of tool if you're dealing with high frequencies. So you see it will go up to 11 gigahertz. So maybe if you are working on pre-amplifiers for high frequency stuff, or maybe for I don't know, antenna amplifiers or such, then this device might be very helpful. But other than that, I do not really see where you could use it. But maybe you guys have some ideas where you would use it for, then yeah, write it down below in the comments. And I mean, even when we talk here about 100 milliwatt, 100 milliwatt is 20 dBm, and you all know that it's not really much. But as I said, maybe if you're dealing in the high frequency stuff, then it really might be helpful. Okay, so let's go into the testing, and let's see how it is performing. Okay, so this device is normally dealing here with a 9-volt block battery. I've set it here to the power supply for heating it up, and for being able to test if it is telling us if the battery is low, because you see the LED light in here, and according to the user manual, this lamp, this LED, simply will switch off if the battery voltage drops below 7.5 volt. So that will be our first test. Okay, so that way we should be able to see both. So let me simply go down here to 7.5 volt, and you see already with 7.5 volt we see here a funny reaction. So that means it is already struggling a little bit here with the voltage, but our LED is still on. So yeah, let me go down to 7.4 volt, and now you see it is really down, it is off, telling us that the battery voltage is definitely too low. So let me go above, and you see at 7.5 the reading is definitely wrong. So we have full scale in with 7.5. Let me see, do we have it everywhere? No, not really. So that is something which happening always only here in the lowest section. But anyways, if we go down here to 7.4, then it is going off. So that is telling me okay, something, or the battery is discharged. And yeah, if we go up to, I don't know, 8 volt, so then you see it seems to be stable. I guess 7.5 volt would be already a little bit too low for finally operating this device, because you see already with 7.6, okay, 7.5, and then it already starts to making trouble. So it is not super reliable, but anyways, if it is off, you definitely know now you have to change it. Okay, what I want to do now, I put back here the battery, not to have any noise here from the power supply at the meter input. So I mean our supply voltage input, because any noise what we are going to transfer from our power supply could be harmful for our reading, and therefore I put back now a battery, and then we do all the tests, of course, with the battery, because you all may know that nothing is more clean than a battery itself. Okay guys, so really have here some trouble with light and camera position and so on. So I hope you're able to read here our dBm value, and you can read here my millivolt meter, which is set to watt. So all what we see here will be in watt, so that is the same like we have it here on our meter. So we start with a scale end 1 milliwatt, which is the upper scale, and we all know that 1 milliwatt is equal to 0 dBm. So I just see that we are not at 0. I mean, that is important. RF is off for the moment in time, so we should have really 0 here at our TPM4, and we are testing with 50 megahertz, and I'm testing here directly at the input, so there should be no loss between what we read here with our Rohde and Schwarz and our TPM4. And yeah, let me simply switch it on. I mean, yeah, our modulation is of course switched off, so there is definitely nothing. Yeah, off. So now it's better. It is off. So we do not have an input from the input here. Anyways, let's switch it on and let's see what we have. All right, so we are reading 80 milliwatt here. Our setting is of course 0 dBm, and that is 1 milliwatt, and we can read here at our Rohde and Schwarz is definitely 1 milliwatt. All right, so you see -3, exponent -3, which is indicating for milliwatt. Okay, and you see here our watt LED, so we are definitely reading in watt. But additional to that, if we switch it to volt, all right, so we see we have 2.225 and 0 dBm is 224. So you see that all is quite right. So the setting here is fine, and the reading here at our Rohde and Schwarz is fine as well. So let's go back here to our watt reading. Okay, I mean, you never will have it that all instruments agree on 100%, so that is not given. So you always have loss over the wire here, and you know, there are little differences here in the output depending on the frequency and so forth and so forth. So there is a lot of what we have to deal with. So therefore it is very seldom that everything is 100% agreeing to each other. And beside that, I'm using not here a thermal head. So there is also a thermal head on the market for our Rohde and Schwarz, which is much more accurate when it comes to reading power, right? So therefore, you know, but that is what I said, I'm not a calibration lab. Anyways, so we are definitely off, so that is what we can say for sure. And now let's go back to 300, or 0.3 milliwatt, which is at least yeah, let me take it volt wise. It would be minus 5.229 dBm, so that is what we already set. And to do it as much as accurate as I can, I use the voltage value, which is 122. So let me give it here 122.47474 millivolt, which we have here. All right, and that should be 0.3 milliwatt, and you already see that our Rohde and Schwarz is totally agreeing on that. Now let me switch it down here, and yeah, that reading is not too bad, but what we don't know is, do we have our 0 point right? Because we always have to correct it, and you see it is not right, so we have to zeroing it out. I hope, yeah, seems to be 0. Now we do it once again, back to output 0.3 milliwatt, 300 microwatt, and again, yeah, so it is more or less the same amount what our meter is out, so that is definitely wrong as well. So therefore let's go to 3 milliwatt, and 3 milliwatt is equal, let me convert it here, so that is what I'm doing. Let me convert it. Okay, and 3 milliwatt is equal to 387 millivolt. 387 point, what is it? 298 millivolt. And yeah, our Rohde and Schwarz is totally agreeing on that, 3 milliwatt. And again, it is the same. Let me see if our 0 is right. More or less, so that is not too bad. So let's go back. And again, so I guess we will have the same all over. So I don't know if you really need to go over 10. I believe it will be exactly the same. 10 milliwatt will be 10 dBm, of course. So let me type in 10 dBm, and yeah, so you see our Rohde and Schwarz is agreeing, and we have here the same picture. So therefore, let's assume, I will test it, but we do not need to go to all steps. You have seen that it is off. I would call it, if we are looking here to our upper scale, it is always approximately 20% off from the end value. So therefore, yeah, let me test all, and then I let you know the result, and then we see what we can do for calibration. Well, yeah, and the result is always the same regardless on here our setting. So therefore, let's see if we can trim in a little bit. Okay, and here we have it, and as you can see, there is not really much to it. So our meter, our selector dial, and then here down there, that is the bridge configuration, some active components down there. We have here our trimmers, where we try to align it a little bit, and what you can see down here. So that is our fully shielded thermal coupler, or however you want to call it. And yeah, so the beauty is that we have 2 holes here in the back, and that means we do not need to have here our unit open. That is quite good, because we should really have it completely shielded, and therefore I put back here our housing, our lid to the unit, to really have as much shielding as possible. And we are lucky, we really have here the schematic of the TPM4, and as I already told you, so that is simply a bridge configuration. So that is definitely very simple. You see here that is our Thermo coupler, and yeah, the Thermo elements are shielded, so that is what we have seen. And then we have here an operational amplifier, and we have here our 0 pot, and we have here where we can do our yeah, so that is the pre-adjustment, whatever you want to call it, and then we can here adjust for sensitivity. And yeah, therefore let's simply see if we can finally bring it into specs. Yeah, by the way, this here is our 7.5 volt power indicator. So if the voltage goes below, it is switching off. So that is this part here down below. So you see, it is really not much to it, and therefore let's see what we can do. Okay, so, and I have a screwdriver here in the back at our pot, and now let's see. So we have 1 milliwatt here at the input, and let's see if we can adjust it to what we wanted. Yeah, that is, I've lost here the pot. Okay, I have to stop it because I need to get my screwdriver back in. So that's a little bit tricky here. Okay, so we try to go ahead. Wrong way. So we have to go that way, obviously. And it is moving. It is definitely moving. And we are at the scale end. So let me do the fine-tuning, because I do not have the right angel to see here if we are really at 1 milliwatt. So let me do it off camera. It is definitely a problem here to do it that way. Okay, so we have here 0 setting, and we have no input. Now let me switch on 1 milliwatt, and now it is in, and let's see. Yeah, come on, so that is very nice. So we are exactly at 1 milliwatt, and when we go up to our generator, so Roder and Schwarz is telling us 1 milliwatt, and everything is just fine. So let me go through here our different settings, and let's see if we still agree. And also our 30 milliwatt setting is almost nice. I mean, we have little differences, we know that it is that way, but you know, it is really nice. And yeah, let me show you our generator. I go up here, and there you have it. We have exactly 30 milliwatt, so that is just fine. So everything is pretty excellent here. Okay, and I've just set the generator to 10 milliwatt, 10 dBm, which is equal. And you see I've left here my selector switch at 30 milliwatt, so that means lower scale. And you see even here on that setting it is green. And now when I go here down to 10 milliwatt, you see it is almost where it have to be. And yeah, let me see, when I go to 100, and we have 10 milliwatt, and you see that is agreeing as well, even in our 100 milliwatt setting. So you see that all looks now really pretty nice, and I'm quite happy with it, to be honest. And here exactly the same game. I've set my generator to 1 milliwatt. Scale end is 10 milliwatt, so our needle is agreeing with it, and even here, so 3 milliwatt scale end and 1, that is fine. And now we should have full scale, which it is, maybe a little bit above, but as lower we go, as more we have to be really carefully here that our 0 setting is right, because it gets more and more sensitive, and you know, all what's around can disturb the values, low values in particular. So that is looking quite good. Okay, so I would call it a success. I know I've only tested it with 50 megahertz. I will do some more additional tests on higher frequencies, but you know, that always gets more and more complicated, because the loss on the wires is higher, and so on and so on. So that is not so easy, but in general I would say it is a success, and for ham purposes it is definitely just fine. So we do not need to be as accurate as somewhere in development for high RF gear. So therefore that is definitely fine. And let me stop the video here. So I just wanted to share with you that it is definitely possible to do calibrations in a way that it is good for ham radio operations, and that is what you have seen. Hope it was a bit interesting to you. Let me stop it here. Thanks for watching, and catch you next time. Bye.